In Algebra 2, we talked about something called polynomial division. And we learned how to do polynomial division in two different ways. One way was longhand polynomial division. So if I want to divide x cubed minus 4x squared minus 7x plus 8 by x minus 5 is called the divisor, and the x cubed minus 4x squared minus 7x plus 8 is called the dividend. The deal with polynomial division, though, is you have to be careful about something called missing terms. I want you to notice in the dividend, the first term is x cubed, and every term after that, the x exponent decreases by 1 in value. So if you have any missing terms, you have to put a 0 in their place. So polynomial division sort of works like longhand division. There are two terms here, so we want to figure out how many times x minus 5 goes into the first two terms of the dividend, the x cubed minus 4x squared. But all we had to do was we had to figure out what we need to multiply x by to turn it into x cubed. Well, we have to multiply by x squared. And look where I wrote the x squared. I wrote it above the second term. Then you multiply x squared by the dividend, and you get x cubed minus 5x squared, and then we would subtract these. The first terms, when you subtract, should always cancel. If they don't, something went wrong. Be careful when you're subtracting. Negative 4x squared minus negative 5x squared is positive 1x squared. And then you bring down the next term. And now we're going to do it again. What do I have to multiply x by so that it becomes x squared? We'll have to multiply by positive x. And now I multiply by x, and I get x squared minus 5x, and then we subtract. These cancel. Negative 7x minus negative 5x is negative 2x. Bring down the next term. Now we're going to do this again. What do I have to multiply x by to become negative 2x? Well, I have to multiply by negative 2, so I'm going to write negative 2 there. And I write negative 2x plus 10. We're going to subtract. These cancel, and 8 minus 10 is negative 2. So we have a remainder of negative 2. We also sometimes write it like this: x squared plus x minus 2 plus negative 2 over x minus 5. So this is the more appropriate way of writing the answer. However, we sometimes just say remainder of negative 2. We learned another way of doing polynomial division last year. It was called synthetic division. It was kind of a way of dividing polynomials, but you can only use synthetic division if the divisor is a binomial whose leading coefficient is x to the first. So the way this works is you set the divisor equal to 0 and you solve for x. You take that number and you stick it in like a little half a box. Some teachers teach it different. This is how I've done it. Next to that little box are going to be the coefficients of the dividend. The coefficients are 1, negative 4, negative 7, and 8. So the way this works is you start by bringing down the first coefficient. And then you're going to write a number above the line under the negative 4. You get that number by multiplying the 1 by 5. And then you're always going to add going down. So negative 4 plus 5 is 1. To get the number that goes under the next coefficient, you're going to multiply 5 times 1. And then you're going to add going down. To get the next number under the 8, you multiply 5 times negative 2. And then you add going down. The last number is always the remainder, and that's the remainder we got when we did the longhand polynomial division. What's left over, the new polynomial, is always 1 degree less than the original dividend. The original dividend started with x cubed, so this is going to be 1x squared plus 1x minus 2 with a remainder of negative 2. So we have something called the remainder theorem. And the remainder theorem says when you divide a polynomial p of x by the binomial x minus r. The remainder is going to be a constant. We're going to call it p of r, such that p of x is going to equal what you divided by times the quotient, and then you add to it the remainder. But we don't always get a remainder when we do polynomial division. So in this next problem, when I go to do my synthetic division, the first thing I'm going to do is I'm going to set the divisor equal to 0 and solve for x. So -5 goes in my box. The dividend has no missing terms, so next to it is going to be 1, 1, -17, and 15. Notice that when I wrote the coefficients, I left space between the numbers. One of the things that often happens is students try to squish the numbers together, and then they can't remember what numbers they have, and so the first two numbers they'll think are 11 instead of 1 and 1. So please be careful. So the first term comes down. Then you multiply to get the next number, you add going down. You multiply to get the next number, you add going down. You multiply to get the next number, you add going down. The last number is the remainder. But I want you to notice that this time the remainder was 0. The quotient is going to be 1 power less than the dividend, and since the dividend started with x cubed, this will be 1x squared minus 4x plus 3. So now we have something called the Factor Theorem. And the Factor Theorem says that x minus r is a factor of p of x if and only if p of r equals 0. Sorry for the sloppy handwriting. So in other words, there's another way of determining the factor, or if a binomial is a factor. Remember, a factor occurs if you have a 0. So r is really a 0, and then x minus r is called the factor. Remember when we were factoring things like x squared plus 5x plus 6? If you graph that in the calculator, you'll see that it hits the x-axis at -2 and -3. Those were called the zeros. X plus 2 and x plus 3 are called the factors. So if you know what r is, you can plug it into p of x. And if you get 0 as the resulting answer, then x minus r has to be a factor. The easiest way to tell if something is a factor or not is to graph it in your calculator and see if the graph hits the x-axis at that value or not. But how do you know what number to look at? Well, if you take this and you set it equal to 0 and solve for x, and then you graph this in your calculator, does the graph cross the x-axis or touch the x-axis at x equals 3? The other way of doing it is to do synthetic division. 3 would be the number that goes in my box. Remember earlier I said you have to watch out for missing terms? Well, here's the deal with this particular dividend. We have an x to the 4th, but it's missing x to the 3rd, so you have to put a 0 in its place. And then we have x squared, but we don't have an x to the 1st. And then we have 2. Whatever the biggest exponent is, the number of coefficients you have should be one more. So x to the 4th should result in 5 numbers. So to help you out, this was x to the 4th, x cubed, x squared, x to the 1st, and that's my constant. Notice there was no x to this 3rd or x to the 1st. We put zeros in their place. All right, so we drop the first number and then we multiply. Then we add, we multiply. We add, we multiply. We add, we multiply, and then we add. Since the remainder is 92, x minus 3 is not a factor. It is only a factor when the remainder is 0. It is only a factor when the graph crosses or hits the x-axis at that x value. There is another way of determining the remainder other than using synthetic division, so I'll do this in a different color. What I could have done is I could have plugged 3 in to this polynomial, and this is called the Remainder Theorem. Basically, the Remainder Theorem says if I plug 3 into the original polynomial, I don't even have to have the missing terms. I'm just going to plug 3 in. And then I evaluate this. The value I get when I'm done evaluating tells me the remainder. So this is another way of determining the remainder of a polynomial. If you want to determine the binomial factors of a polynomial, you can use synthetic division to test some values out. But the easiest way is really to just graph it in your calculator and then find the zeros. So if we graph x cubed minus 5x squared minus x plus 5, we get this graph. Well, it's very easy to see that it looks like it hits at x equals -1, x equals +1, and x equals 5. So if those are the zeros, then the binomial factors are x plus 1, x minus 1, and x minus 5. And since it's a cubic function, that means there are got to be 3 zeros, so it turns out that this is the factored form. If you're not sure if that's where it hits the x-axis, you can always go to the table. If we look at the table of values, a 0 occurs anywhere where the y-coordinate is 0. So we can see on the table that the graph hits the x-axis at -1, +1, and 5. The last thing that we're going to do is we're going to use our understanding of the remainder theorem to help us find a value in a polynomial. I want to find the value of k so that the remainder of x cubed minus 7x plus k divided by x plus 1 is 2. Now, we're going to set this polynomial equal to 2 because the way the remainder theorem works, it says if you take the divisor, set it equal to 0, and solve, and then you take that number and you plug it into a polynomial, the answer you get is the remainder. So what we're going to do is we're going to plug in -1 for x, and then we're going to solve this equation for k. Again, the way the remainder theorem works is if you set the divisor equal to 0, solve for x, and you plug that number in for x into the dividend, the answer you get when you're done simplifying is the remainder. So this is going to be -1, because that's what you get when you raise -1 to the third, plus 7 plus k equals 2, 6 plus k equals 2, so k is equal to -4. So in order for the remainder to be 2 when you do that division problem, k needs to equal -4. And that is the factor and remainder theorems.